Okay, so what I'm going to go over right now is based on a question from one of your classmates. Good question. Is locating the angles that correspond to certain values of tangent, because we seem to have a hard time knowing that. I think that you guys are really getting the hang of sine and cosine as it relates to the unit circle, but the hard part is tangent. So I'm going to show it to you 3 different ways, maybe. Maybe I'll just keep it down to 2. So I'm not going to draw out the entire circle here. I would assume that you know where the angles are, or that you have that in front of you or accessible to you, and that you more or less know sine and cosine everywhere. However, I'm going to draw a little bit of a circle, and I'm also going to use the quotient identity to help me out. So tan of theta by the quotient identity equals sine theta over cosine theta. So again, if you know sine and cosine pretty well, well, then that means that you can figure out sine, you can figure out cosine, divide them, right? And bam, you have tangent. So this is more of the long, show all your work kind of way, which I wouldn't recommend. And then I'm going to show you like the cheap trick way on the side. Okay. So I'm just going to sketch a quick circle. Okay. There we go. So on this circle over here, it's on the XY plane. I'm not going to clutter it up too much, but these 4 tick marks are kind of representative of the quadrantal angles, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, in the middle of each of those are the quarter or pi over 4s, which also go with 45 degrees. And then here, it's not exactly in the middle. It's a little closer to 45 or pi over 4 than it is to 0. We have another tick mark here. It's really counting by degrees. It would be 30, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. I actually think counting by degrees is really hard. All right, now from here, I'm just going to throw a little color on it. Everything I color in pink in radians is going to be pi over 6, or have 6 as its denominator. I'll try to make that a little bolder because the brightness is up so high, it's hard to see. Those are all pi over, oh, that one went in the wrong place, huh? I'll do a darker color over it. The ones in the middle here, I'll do purple. Those are all my pi over 4s. There we go, kind of. And these are pi over 3. Top and bottom, left and right. Top and bottom, I have pi over 2. And left and right, we have pi over 1, 0 pi. I don't know how green that looks, but 0 pi, 1 pi. Go back around, you'll have 2 pi. Go back around, 3 pi, and so on and so on. Okay, so those are my angles. Again, I'm not going to label it with all of them, but here, that is 0 or 2 pi. If I wanted to know the tan at 0, it would be equal to the sine of 0 over the cosine of 0. That's the y value at 0 radians, and that's the x value at 0 radians. What's the sine of 0? You guys could just shout it out if you have that answer in your brain. What's the y value? If this is the xy plane, right? And this is the origin that I'm about to pass through right here is the origin. It's the unit circle. It means the radius is 1 unit. Then what is this ordered pair? The radius is this. X comma y. Y is sine. So what's sine of 0?
0.
Good. And what's cosine of 0?
1.
1.
1.
Good. Thank you. Thank you. Good. And then 0 over anything other than 0 is what I would normally write as an abbreviation to help you remember. 0 over 1 or 0 over something is okay. And that equals 0. Okay? That is a 0. So tangent, I'm going to put all the tangent answers. This is going to be my special tangent circle, okay? All the answers on this circle are only going to be tangent, not sine or cosine. It's a special circle for you of just tangent answers. So tangent is 0 right over here. Done. Here, it's also 0 because instead of being 0 over 1, it's just 0 over -1, and 0 over something is okay. It's just 0. So that's 0 and 0 for tan. What if I want to do over here, and I'll put little color markings on here in a moment, tangent of pi over 2. Again, this is the long way to do this. You would do sine, and I don't recommend it. It takes too long. I'll show you the trick, and you'll see the difference in how fast it could be. What's sine? Remember, that's the y value of pi over 2.
1.
Thank you. Thank you. And what's cosine of pi over 2?
0.
0. Good. And now here, why am I putting 0 on top? When you have a number divided by 0, when you have a number divided by 0, other than 0 over 0, 0 over 0 is something we call indeterminate form. You'll talk about that when we do limits and whatnot. But when you have something over 0, we don't have it okay. That's no. So what does that mean for no? No means that this is undefined. So what does that tell me about tangent? Tangent is undefined here at the top blue, and it's undefined down here at the bottom blue as well. Undefined, undefined, because here it's just going to be -1 over 0. Here it was just +1 over 0. So far we have tangent is equal to 0 at those two spots, at the left and at the right. And then we have that tangent is equal to, it's undefined at the top and bottom. We shouldn't say equal to undefined, it is undefined. Next, I'm going to do tan of pi over 6. Tan of pi over 6, well, that would be sine of pi over 6 over cosine of pi over 6. Again, we're better at these, I hope. What's the sine of pi over 6?
1/2.
Half.
Nice. And then cosine of pi over 6 is?
√3 over 2.
Thank you, thank you. Keep, change, flip. I think a lot of you say to yourself when you see something like this. So keep, change, flip. All very annoying stuff to do over here. The 2's reduce. You do not have to multiply them first or anything, like anything from top and bottom. When it's all multiplication and division, no plus or minus, you could reduce. Now I have 1 over √3. You should know by heart what that equals if you rationalize it. What does that equal? After you multiply the top and bottom by √3, what do you get?
√3 over √3.
√3 over 3. So all of the pink are going to be associated with √3 over 3. However, we also need to remember back in like lesson 6, 7, 8, somewhere over there, we were going over quadrants where tangent, where sine, cosine, tangent, secant, cosecant, cotangent are positive and negative. Does anybody remember which quadrants tangent is positive or negative in? Who remembers which quadrant?
I think tan is positive in quadrant 1 and quadrant 3.
Yes, good. Thank you. That was Victor. Right, I think. And then it would obviously then be negative here and here. Now I'm going to go ahead. I'm going to do a tan. So instead, this is pi rad 3 over 3. Tangent here will just be negative rad 3 over 3. Here it's positive, so positive rad 3 over 3. Here it's negative, so it's negative rad 3 over 3. All the pink have the same answer. So the only thing that would change is whether it's positive or negative. All right. Tan of pi over 4. This one really, you should be able to reason out because pi over 4 is a 45-degree angle, and a 45, 45, 90 triangle is the right isosceles triangle, meaning that the two legs are congruent. Congruent means they're the same length. So if they're congruent, then the answers are the same for both of them, and anything over itself is blank. But if we did it the long way, what is sine of pi over 4?
√2 over 2.
What about cosine of pi over 4?
√2 over 2.
Exactly. And again, anything over itself is, get your participation in, ladies and gentlemen.
1.
Thank you.
1.
1. Good. So here at the purple, I have 1. I'm going to highlight the answers in yellow in a little bit. That means over here, it's -1. Here, it's 1 positive again. Here, it's -1. Okay? These I'll put in a circle so that they don't mix up with the other stuff. The sine and the quadrant. All right, 1 left to do, and that is the tan of pi over 3, which is going to be sine of pi over 3. This is like a nightmare, right? Cosine of pi over 3. What's the sine of pi over 3?
One half.
Sine of root 3 over 2. Yeah, careful. And then cosine's 1/2. Then we do keep change flip again. Root 3 over 2 times 2 over 1. 2's are gone. And we just get root 3. So over here at the orange is root 3. That means that's negative root 3, positive root 3, and negative root 3. So my tan answers, tan, I'm just going to highlight the answers in yellow. I'll have 0, root 3 over 3, 1, root 3, undefined. And then the answers at these other places are going to align with the matching color check mark for an angle. And you figure out the sign by just looking inside that parenthesis over there. And you'll see positive, negative, whatever you need. That tells you the sign, S-I-G-N, of tangent at those places. But that was so long and tedious torture, right? I did show you and tell you my story about an individual character person I made up to just help you memorize it and know it a little bit more quickly. Does anybody remember the little story I told? You don't have to like go through what it was, but does anybody remember what I used to show you guys the answers for tangent a while back? What was it? Emerson, you remember?
The tan.
Yeah. Okay, so I drew a little man and everything. So there was tan, the meditating man. He's this wise, bald man sitting at the top of a mountain, meditating. He's at peace with everything. All right, he's wearing a toga. I don't know why, because he has a simple life. And his hands are doing that little curly Q thingy, you know. And he's just sitting, thinking about everyone and everything, contemplating individuals. Those are little claw hands, so pardon my artwork. Okay, there we go. Beautiful. He's meditating and he's sitting pretzel style over here. So his little skinny legs are sticking out. There we go. Here's his toga. And he's sitting at the top of a mountain thinking about life. Tan, the meditating man. Okay, now he's in his mind. Here's his thought bubble. He's thinking about how everything above him in the universe, there's no way you could define those things that are up in the sky or in our minds. Everything is undefined. He's having like that philosophical thought, you know? And he's also thinking about all the people on the planet, and there's no way to define each individual. Everyone below, down on earth, they're undefined. Everything above him in people's thoughts, undefined. His hands are doing the little meditating O's like this. So those are zeros. So this is tan, the meditating man. And he's really tan because he sits outside in the sun all day in his toga. So he gets a lot of sun, okay? Tan, the meditating man. His eyes are closed. He's just relaxing, okay? Now, he's very wise. So he's pretty logical. He has a lot of common sense. So what are some other thoughts he has? He thinks to himself, well, 3 and 3 make 6. And he uses that to remember that the tan of angles over 6 are going to be equal to either positive or negative root 3 over 3 because he's so wise. He's just a wise guru of a guy, you know? So that's some logic he uses. Then he thinks about how 3 just goes with 3. So tan of any angle over 3 on the unit circle, it's going to be either positive or negative root 3. Okay? So little shortcut so he doesn't have to do all this extra work. All right? And then lastly, tan of any angle over 4 any angle over 4, he thinks, well, if I connect the 4 angles that are at the 4s, right? So here's where they were. 1, 2, 3, and 4. Those are the ones in the middle. And if we connect them, we make one perfect square. Okay, so those are equal to 1. We get one perfect square when they're all in the middle. All right, one big block right there. 4 is a perfect square, 1's a perfect square. I don't know, do what you need to do to remember it. So it's either 1 or -1. Really, I should put a plus minus right there. Okay, so above him, below him, undefined. On the sides, 0. And then he's so wise and smart, he just uses a couple little tricks over here. He knows 3 and 3 makes 6, so root 3 over 3 goes with the tan of pi over 6's. He thinks 3 goes with 3, so tan of any angle over 3 is root 3. You just need to figure out what quadrant it's in, if it's positive or negative. And the tan of pi over 4, it's the 1 straight in the middle. And when you connect them, you make one big perfect square. It's the 1 in the middle, okay? Now tan, so this is again, tan, the meditating man. This is just some stupid thing. I used to always make something, make up stuff to help me memorize things. So I just had a story in my head, okay? He has a twin brother. His twin brother is, they have a lot in common, but they're also quite different. His twin brother is cot𝜃, okay? So here, while tan𝜃, the meditating man, gave up all of his belongings, lives on a mountain wearing a toga, and meditates all day, well, cot𝜃, he wants to work on Broadway, be a dancer. He has jazz hands. Those are his jazz hands, like spirit fingers, like this. And he's got the best jazz hands on Broadway. No one could define those jazz hands. They're just incredible. Okay, so this is them being jazzy. Okay, there we go. Beautiful. There's his arms. But he's got 0 brains. Okay. He doesn't know much of anything, but he's got great jazz hands. Okay. 0 brains. He gets lost on his way to work every day. He doesn't know which, that he should put his pants on one leg at a time. He gets confused. Okay. Not the wisest guy. And then also, even though his jazz hands are unbelievable, he actually has 0 talent dancing. He wants to be a tap dancer. He is awful. The worst tap dancer ever. 0 talent, 0 brains, 0 dancing talent, 0 brains, top and bottom. But those jazz hands cannot be defined. They are amazing. All right. And then he's a reciprocal. So the 4 in the middle, tens of 4s, what's the reciprocal of 1? It's just 1. So he's still 1 at the same place, but at the 6s and the 3s, it's some reciprocal action. So the reciprocal of root 3 over 3, what's the reciprocal? What's the reciprocal of root 3 over 3? We memorized it back in lesson 1 and 6. Radical 3 over 3. The reciprocal is? No one? Ladies?
Is it root?
Gentlemen, go ahead.
Is it root 3?
Yes, root 3. So that being said, what's the reciprocal of root 3? Not a trick question. It's that easy. What is it?
Root 3 over 3?
Yeah, it's interchangeable. It goes back and forth, okay? So if these are the reciprocals and the twin brothers are reciprocals, everywhere tangent is one thing, cotangent is its reciprocal, What's the reciprocal of 1? Well, we just said the reciprocal of 1 is? Guys, this is where you jump in and participate and
1.
yes, thank you. 1, okay? So those are my silly ways for remembering the answers for tangent and cotangent. I don't know if it helped you or not, but in either event, that's the silly way. This is a little bit more of a proper way. So I'll save this. Hopefully this helps you work a little faster through tangent and through cotangent, all right? Any questions before I stop recording?
Could you pull up the page a bit?
Oh, Which way? You
Yeah,
want to see the
definitely
bottom?
top of it. I mean, yeah, the other way.
Like pull it down?
Yeah, got it. Thank you.
I
That's
could
good.
even, let me, how does that? Because I know on YouTube it'll be okay, but I know on the Google Meet that the stuff around like blocks it, right? Can you see it okay with this view?
I got it. Yeah.
All right.
Thank you.
Yeah, no problem. Anyone else questions before I stop recording just to make sure it's in the video if you need it? Emerson, do you want something about this? Is that a yes?
I mean, I just wanted to see the page again.
Okay. So does anyone still looking at this page? All right. Here's my other silly page. Oh, I could circle this stuff before. There we go. And I could maybe put the colors that correspond to the other side. So I think we did, those right there for blue. 6s, I did pink. The 4s, I did purple. I don't know if it's gonna, I always get worried the purple's too dark. That's all right. Okay. Then green. And I think 3s I did orange. Okay, so that's tan𝜃, the meditating man. He's so wise and smart, and he helps us know the tangent values by heart. I'm so rhymey right now. Okay, nothing else? I could end the recording. All right, so if it helps you, let me know that it was helpful. And if it's not helpful and you need some other method or you want like flashcard of some sort, like something to drill and practice to memorize it, you know, put a thumbs down. I'll do something else to help you guys out, okay?